Good day, Teacher Eloi here. Today is the second day of our lesson. We're going to describe the characteristics of the uniform mixtures and non-uniform mixtures. Before we proceed, try to identify which among these mixtures can still distinguish its components. Alright, so we have mixture A, mixture C, and mixture D. You can still distinguish the components of these mixtures. Reflection time! So, just listen well because this one is very important. So, from your last experiment, our mixture A, so we have salt and water as our components. When it is combined, we had a liquid phase. Now, can you still distinguish the components? Of course not. Since the salt cannot be seen, it means that we have what we called a cannot be distinguished type of mixture. And when you can distinguish the components, it is what we called a homogeneous mixture. Alright? Again, since the salt can't be seen, it means that we have a homogeneous mixture. Same as with mixture B. The phase after combining the substances is only liquid. This is homogeneous as well. Now, look at mixture C and mixture D. Mixture C and mixture D tells us that the components can still be distinguished. You can see oil and water, right? You can also still recognize the two phases when you combine the substances of the two, the oil and the water. Same as with the gravel and oil. Mixture C and mixture D are both heterogeneous. We have using these terms for the last 3 days, so now what we will use is homogeneous for cannot be distinguished components of the mixture and heterogeneous as can be distinguished type of mixture. Remember that a mixture can be identified easily because the individual parts are visible. They are combined but could easily be separated. No new substances when the new substances combined. Now, there are two types of mixtures. The first one is the uniform or homogeneous mixtures. Uniform or homogeneous mixture is a mixture with only one phase, meaning that you cannot identify one substance from another. Examples of this kind of mixture are sugar and water mixture, fruit juice, and syrup. Sugar and water is homogeneous since you only see a colorless substance liquid in the mixture. Now, here are some other examples of homogeneous mixtures. Vinegar. Most of the vinegars you buy in supermarkets stores are homogeneous. The water dissolves in acetic acid. Moreover, mixing water and vinegar is also homogeneous mixture because they mix evenly or they mix well. How about air? Yes, air without clouds is homogeneous. Air is a mixture of gaseous substance nitrogen, oxygen, and other substances like hydrogen and helium. Now, juice is homogeneous when the juice powder was mixed in the water. Now, let's have the opposite of uniform mixtures. The non-uniform mixtures are heterogeneous mixtures. Non-uniform is another term for heterogeneous. The easiest way to know whether a mixture is heterogeneous is if you can still see the materials apart. Examples are halo-halo, soil mixture of water, gravel, and sand. Other examples are trail mix, hamburger, and rocks or stone. Rocks are heterogeneous because natural processes have mixed up sand and some living things. Now, air with clouds is heterogeneous, as clouds contain tiny droplets of liquid and water. Remember that the juice will only be heterogeneous when the juice contains a pulp, as well as liquid. Now, write 3 examples of uniform mixtures and another 3 examples of non-uniform mixtures. Describe them. Write it down on your notebook. Now, to sum up everything, watch this.
Mixtures can be homogeneous or heterogeneous mixture. Mixture can be combined in different ways and are classified as either heterogeneous or homogeneous mixture. Let's talk about these. A heterogeneous mixture is a mixture that doesn't have uniform composition. The composition of heterogeneous mixture does not blend throughout. The individual substances or the components are recognizable or remain distinct. The phases or substances are all visible. For example, a freshly squeezed orange juice or the landan juice is a heterogeneous mixture of juice and pulp. The pulp component floats in a juice component. Some other examples of heterogeneous mixtures are beach sand, fruit salad, and air with clouds. Beach sand is heterogeneous since you can see different colored particles. Air with clouds contains tiny droplets of liquid water. Now take a look at the other examples of heterogeneous mixtures that you can actually find around us. Now let's talk about homogeneous mixture. A homogeneous mixture is a mixture that has uniform composition throughout. Homogeneous mixture could be in liquid or solid form. Only one phase is seen or visible after mixing the different components. Corn oil, vinegar, and sugar solutions are homogeneous mixtures, since only a colorless liquid is observed. An alloy, for example, is a homogeneous mixture. It is a mixture of different melted metals. Another example is air. The air with no clouds is homogeneous. It is composed of oxygen, nitrogen, carbon dioxide, and other particles. Now take a look at other examples of homogeneous mixtures.
So, you just have learned the difference between homogeneous and heterogeneous mixtures. Now, for your activity, identify if the following is homogeneous or heterogeneous, then describe its characteristics. I'll give you 1 minute. Alright, let's check. So air with clouds, homogeneous. Air without clouds is what? Alright, number 1, correction. Air with clouds is heterogeneous. Air without clouds is homogeneous. Number 3, T, homogeneous. Number 4, still heterogeneous. Number 5, serial heterogeneous. Once again, air with clouds is heterogeneous. Air without clouds is homogeneous mixture. Alright? By the way, congratulations! Once again, this is Miss ELOISA, your teacher. Goodbye!